Okay, so we've had a look at highest common factoring. We've also had a look at special factoring with difference of squares. Now we're going to take a look at monic quadratic factoring. So this is what's known as monic quadratic factoring. So a quadratic is a polynomial of the form ax squared plus bx plus c. This is a quadratic. This is also referred to as a second order polynomial. Polynomial. Now, if a is equal to 1, then the equation becomes y equals x squared plus bx plus c. This is what's known as a monic quadratic. This is where b and c are just some number. So b and c are included in the real numbers. So they could be whole numbers, they could be decimals, they could be positive, negative, whatever. Monic quadratics have a very special type of factorization. What we're going to do to begin this is we're going to show why we feel these should be factorizable, and then we're going to prove that they definitely are factorizable in certain cases. So if we have a monic quadratic, we're going to take this monic quadratic x squared plus bx plus c, and we are going to assume that this can be written in the factored form x plus alpha times x plus beta. So this is an assumption. Assume. Now we are going to expand the right-hand side using FOIL expansion. X times x gives us x squared. X times beta gives us beta x. Remember, alpha and beta are numbers. So alpha and beta are included in the reals. That's what this means. Alpha times x is going to give us alpha x, and then alpha times beta is going to give us alpha times beta, which is alpha beta. All of these are positive, so these are all added. Add. This is equal to x squared plus alpha x and beta x are like terms. So we could add them together and we could call this alpha plus beta times x plus the term at the end is alpha beta. Now we can see from inspection that whatever the number in front of the x is must be the same as alpha plus beta. So capital B must be equal to alpha plus beta. So we get that B must be equal to alpha plus beta. And then we also see that the number at the end must be equal to alpha times beta. So we find that C must be equal to alpha times beta. And this is where we get our rules for factoring monic quadratics. If we are given a monic quadratic, we are looking for two numbers which add to make B and which multiply to make C. So add to make B and multiply to make C. So let's have a look at an example, and we'll take a relatively simple example. So we might take x squared plus 7x plus 6. So here we have the b value is in front of the x, so b is equal to 7. The c value is the number on its own, so c is equal to 6. Now we are looking for two values in the factorization x plus alpha times x plus beta. The two numbers must add to make b. So whatever these two numbers are, alpha and beta, they add to make 7, and they have to multiply to make c. So whatever the two numbers are, they multiply to make 6. So now we just have to work out which two numbers add to make 7 and multiply to make 6. Well, this one's pretty easy. It's going to be 1 times 6 is 6 and 1 plus 6 is 7. Whenever you're doing these, you always want to think about the product pairs. You want to think, well, what pairs possibly give me 6? So we've got 1 times 6, we've got 2 times 3, we've got -1 times -6, and we've got -2 times -3. These are all of the whole number slash integer pairs which multiply to give us the number 6. So when we're doing our monic factoring, the alpha and beta are always going to be one of these sets of numbers. And if they're not one of these sets of numbers, then you're in trouble. Then the alpha and beta are going to be fractions or something like that. Then monic factoring is not going to work particularly well. Then you need to use some other method. So here we identified that one of these is 1 and one of these is 6. So we'll say this is x plus 1 times x plus 6. So this is our factored monic quadratic. So let's write down some examples and you can have a go at these. So question 1, we will go with a squared plus 2a minus 8. We will go with, maybe for question 2, we'll have t squared plus 23t minus 50. And then the third one, we might have, for question 3, we might have 5a squared minus 5a minus 30. So pause the video now and have a go. All right, so now that you've done this, or attempted these 3, let's go through them. So we want to write this in the form a plus alpha times a plus beta. We know that the number in front of the linear term, capital B, is equal to 2. The number at the end, capital C, is equal to minus 8. Now keep in mind, if these are negative, the negative goes along with them. So we're looking for 2 terms, alpha and beta, which add to make 2. We're looking for 2 terms, alpha times beta, that multiply to give us minus 8. Let's think of the pairs of numbers that multiply to give us minus 8. We have minus 8 and 1. We have 8 and minus 1. We have 2 and minus 4. And we have 4 and minus 2. Well, of these, the only ones which add to give us 2 are 4 and minus 2. So therefore, one of these is 4. So we have a plus 4 times a minus 2. And if you expand that through, you'll find that you get a squared plus 2a minus a. Let's have a look at question 2. So we want this in the form t plus alpha times t plus beta. We know the number in front of the t term on its own is the capital B, so capital B is 23, and the number at the end, c, is minus 50. So now we're looking for 2 numbers that multiply to give us minus 50, add to give us 23. So let's think of pairs for minus 50. Well, we've got minus 50 and 1. We've got 50 and minus 1. We've got 25 and minus 2. We've got minus 25 and 2, and so on. Well, in this list, we can immediately see the one which adds to give 23 is positive 25 and minus 2. So therefore, our monic factoring is going to be t plus 25 times t minus 2. Now, let's have a look at question 3. Question 3 is a little bit different. It is not a monic. It's what's called a non-monic. It's something that has a non-1 number in front of the a squared. However, this is a trivial non-monic. So this is what we sometimes call a trivial non-monic. Something which is trivially non-monic is easily factorable into a monic. So every coefficient in this expression is divisible by 5. Divide by 5, divide by 5, divide by 5. This gives us 5a squared divided by 5 is a squared. 5a minus 5a divided by 5 is minus a. Minus 30 divided by 5 is minus 6. Now what we have in the brackets, this is a monic. So if you are given a non-monic, first try to turn it into a monic by dividing everything by the squared term's coefficient. If that doesn't work, you're going to have to use a more complicated method, and we'll deal with some of those later. But if something's trivially non-monic, turn it into a monic and then factor it that way if you can. So now, The number in front of the A is -1. So the capital B is -1. The number at the end, C, is -6. So we're after two terms that add, alpha plus beta add to make -1, alpha times beta multiply to give us -6. So let's think of the product pairs. -6 times 1, 6 times -1, -3 times 2, and 2 minus 2 times 3. Well, of these four, -3 plus 2 is -1. So one of them is -3, one of them is 2. So this can be written as 5 times A minus 3 times A plus 2. And if we want to confirm this works, we know how to FOIL expand. We can FOIL expand this, do a coefficient expansion at the end, and we should end up with what we started with. So this is a check. So let's check this one. Let's check. You want to get in a habit of checking whenever you can. It's a really good habit to be in, especially in exams. So we're going to leave the 5 out the front. A times A is A squared. A times plus 2 is plus 2A. -3 times A is -3A. -3 times plus 2 is -6. So this is 5 in front of A squared minus A minus 6. Expand this, we get 5 times A squared is 5A squared. 5 times minus A is -5A. 5 times -6 is -30. This is what we started with. And because it is what we started with, this is definitely a correct factorization of this trivial non-monic.